Good morning, intro to robotics class. This is going to be a short presentation, just giving some important information to you for the week and for the rest of the month. So, important dates going forward. So, we want to let you know sort of what the next month looks like because there's some important dates coming up for both us and for you that me and Mr. Wei felt you should know for going forward within this course, whether you want to work ahead or whether you just want to plan the next month at, to the end of the school. So, first, week of May 11th, which is this week, we're going to be covering just basic breadboarding and coding. Uh, Next week of May 18th, we're going to start Arduino with 3.4 Hello Arduino Blank. Um, Week of May 25th, we're going to start 3.6 Arduino Advanced Circuit Challenges. Week of June 1st, 3.7 Arduino Final Project. And then for the final assessments within our course, we're actually going to have interviews with you, personal one-on-one interviews through Google Meet. These interviews will take place June 1st to June 4th. What we need from you for that June 1st to June 4th interview is for you to have completed as much as you can within your ePortfolio. So remember, how the course works is we assess you by the level of project that you have completed. So what we would like to see when you come to the interview is the level that you feel comfortable completing up to in each of the different modules. In that interview, we're going to go through your ePortfolio with you, and we're going to identify different parts of your ePortfolio that we wish for you to explain. So for example, we may ask you to draw some simple part in Tinkercad or in AutoCAD. We may ask you to explain how to do a Ohm's law calculation. We may ask you to put together a basic circuit in Tinkercad. Anything in your ePortfolio that you've completed, we may ask you to explain in that way in the Google Meet individual meeting with us. Um, just to note, we're going to have that meeting earlier in the week so that if there's anything come up that we ask you to revise, you can hand in by June 5th. June 5th is the last day for work to be submitted. Okay, so there's two things you need to know. Please complete all the work you would like us to assess before your individual interview. And then, based on our feedback, you're going to have until June 5th to finish up any details that we identify for you that you may wish to improve upon. June 8th and 9th, possible follow-up interviews. So if there's something we come across in our final assessment of your ePortfolio after June 5th, we may ask you to come in for an additional interview to identify any anomalies we might find. This week, we're going to be doing coding basics and breadboarding. So the first thing I'd like to point you to is Lab Under the Stairs webpage 3.3 Coding Basics. There are two things that you could possibly do to complete this page. Either or are due at the end of the month. The first is you can go to code.org, choose their 20-hour accelerated introduction to computer science course, ignore the unplugged activities to decrease the amount of work that you actually have to do. So don't do the unplugged activities, just do the other activities that are present on that page. Complete it, take take proof of that completion, put it in your ePortfolio, and you'll be done. Okay, you have until the end of the month, you have until the end of May, so you have another 3-ish weeks to complete that code.org if you need. If you happen to be lucky and you've taken our computer science course at Nelson Mandela or taken an equivalent, take proof of that completion of that computer science course, put it in your ePortfolio, and ask us to assess it. Okay? Again, either the 20-hour code.org course or proof of your completed computer science course at Nelson need to be in your ePortfolio by the end of the month if you would like credit for coding basics. This week, we're going to ask you to complete just the basic breadboarding circuits. So the basic circuits that are found on the Lab Under the Stairs page 3.2. So to complete these circuits, the first thing that I'm going to talk to you about is reading resistors. So if you come to a whole pile of resistors, you'll notice that they're kind of small, and if you printed something on them, it'd be very hard to read. So to sort of work around this, what they've come up is a band coding patterns. So what you'll notice is that you can have a 4-band code or a 5-band code. Those bands correlate to different values or numbers. So it's read left to right, and as you can see, a black code in the first 3 bands of a 5-band code would correlate to a number. So for example, this first band is 5, which would be a number of 2. Second band is orange, which would correspond to a number of 3. Third band is violet, which corresponds to a 7. So the first 3 bands are read 2, 3, 7. Your fourth band would be your multiplier. So 1 ohms, 10 ohms, 100 ohms, 1 kiloohm, and so on and so forth. Okay, your fifth band will be the tolerance of that resistor. So reading this code from left to right, we have 2, 3, 7. Our multiplier is 1 ohm, and our tolerance is plus or minus 1%. 237 ohms is the amount of resistance this resistor will provide, plus or minus 1%. Last is the anatomy of breadboard. So we really want you to understand the anatomy so that when you go into Tinkercad and you start building your circuits, you have the ability to understand what's going on. So what you'll see when you go into Tinkercad is a breadboard that looks similar to this. We have 2 vertical lines that are running on the left-hand side of our breadboard and the right-hand side of our breadboard. We then have a grid pattern that is denoted by row 1, 2, 3, and then further broken down into row 1, slot A, row 1, slot B, C, D, E, a gap, F, G, H, I, J. So if we take apart, if we dissect that breadboard and we actually look at it, what these correspond to is 2 vertical lines of metal and then individual rows of metal, gap, other individual rows of metal. So as you can see, this would correspond to vertical line, where our positive value is, a vertical line of metal, where our negative value is, okay, and then our rows 1, 2, 3, 4, 5, all the way up to 30, and our slots A, B, C, D, E. What you'll notice is that all the vertical rows on the side are connected through one continuous metal strip. Our horizontal rows are connected to the gap and then on the other side of the gap. So we have a metal strip that runs A, B, C, D, E, and then we have a second metal strip that runs F, G, H, I, J. Okay. When we go to connect our circuit, these metal strips allow us to connect different parts. And I will go through this further in Tinkercad in the later demonstration. But what you need to know right now, if I take a resistor and I connect one of the terminus to 1A, and then I take a wire and I connect that wire to 1E, this middle strip will connect the end of the resistor to the end of the wire, allowing the circuit to be, this metal strip allows the circuit to allow those electrons to flow. So keep in mind this anatomy of a breadboard as we go into Tinkercad and we start to build those circuits.